Hello everyone, my name is Don Phillips, MBA student at University of Wisconsin-Oshkosh, and I'm here for the 754 class, the Information Systems and Organizations, and this is my Emerging Technologies report that I'm happy to bring to you. Basically, the reason that I came up with the topic that I came up with, which is 3D printing, is because I saw it on the cover of an Economist magazine and I threw it away. I didn't read it, and when this assignment came up, I thought to myself, what a dummy, why'd I throw it away? And I had to go back and look up the article and do some digging on it, and it was very interesting, and I'm going to share with you a few things like why it's interesting, how it's going to change business, how it's changed business, and get into some interesting discussion points about it. So right now I'm going to show you just what the cover of the Economist magazine looked like and get into some of the presentation. All right, here's the article in The Economist. It's called "The Third Industrial Revolution. The Digitization of Manufacturing Will Transform the Way Goods Are Made and Change the Politics of Jobs, Too." Just to paraphrase real quickly a little bit about the article, as you can see, there's a gentleman here at a computer, and he's manufacturing parts. They look like they're pretty complex parts, and the whole notion is that factories cannot produce the level of complexity of parts that are being produced, and 3D printers are a way in which that can be done. And customers are really looking for much more specialization of products and a level of customization that factories just aren't able to offer because of the product life cycles can be so quick, and technology has come so far that it can actually move as quickly as the market. So I'll include this in my references in the presentation so that you can access it as well. Okay. Now for the actual presentation, we're going to kind of take it piece by piece, and what I mean by that is we're going to go through some slides, and I'm going to interject a few videos for your viewing pleasure. I think it's going to add quite a bit to the presentation. I've got one from YouTube that we'll only watch part of. I've got a video from the New York Times, and then another little short interview from where I work. So this is my Emerging Technologies report on 3D printing. So 3D printing is actually, it's a process of joining materials to make 3D objects from a 3D model data. So basically, as opposed to taking away material, so as opposed to taking a solid piece of metal or a solid piece of plastic and grinding out, removing, and drilling away material to make a part, this is actually adding to it. So you're starting with blank space and adding layer upon layer of material. So this material could be plastic, this material could be metal. It can be up to over 100 different types of material that can be layered and formed in a very specific way to get what you need. And it's commonly used for prototyping and designing components. So usually used in at the level of business where concepts are just at the very early stages, and they're moving from an idea into the early stages of an actual product that you can touch, feel, and start experimenting with. So use and application. After I go through this slide, we'll take a look at the homemade 3D printer in use. It's quick and easy to experiment with your ideas. So you have an idea, you're able to quickly and easily move that idea from theory into practice, and it reduces time and cost. This technology, while it's not necessarily new by any means, it's now gotten to the point where it is in fact quite cost effective, and thus it's more available to more people, and at a price point where more people can afford it. Reduced cost of entry has opened up a wide market for business in particular, and the industry has exploded. So let's take a look at this video. It's a YouTube video. This is a homemade printer that some person rigged up in their basement, and as you can see, it's printing a head. It's actually Walt Disney himself, and this is the heated tip on the top that is injecting the plastic, and the base here is moving around so that the tip can stay stationary and do what it needs to do, while the base itself does most of the work of getting the actual feature into place. So it looks like a pretty elaborate piece of machinery, but I've heard of these actually selling for something like as low as $250, like a do-it-yourself kit. That's according to an engineer that I work with. So that gives you an idea of a 3D printer in action. Now moving on to the next slide, I wanted to bring up an example of a business, Object Ltd. It's an Israel-based company. As of June 21st, 2012, they had controlled 90 different materials. Now they're up to 107 materials that can be made from a 3D printer, which the article that this came from was pretty thrilled with that new development. They also offer increased quality, and in addition to the wide selection that they offer. It's contributed to, this particular company has contributed to reducing the material costs to operate the printers. So you need not only reduce cost of the printers, but also reduce cost of the materials in order to make this work. Another example, Bespoke Innovations. This is a company out of San Diego, California. They claim to be one of the leaders in desktop manufacturing, where they're able to make one product per person concept. And the one product per person concept, as we'll see in the video, is really designed and geared to what's called extreme customization. In their business, they work with prosthetics, and so as you can imagine, one prosthetic is built for one person. And so desktop manufacturing, or basically 3D printing, is able to help their customers with that specific need. So let's go take a look at the video. Sorry for the shakiness a little bit here, but it's very fascinating video. Make it big.
Are there other
Sorry for the commercial.
What if my returns no longer return?
So what do I do with my money?
See if I can skip it. There I am. Hi.
A new breed of machines can create objects, not quite out of thin air, but close.
It's almost like think of like a little tube of toothpaste that as it squeezes out this, like a molten plastic, that as it finishes, it hardens the plastic, and then it goes on to the next layer, and it builds that up layer by layer by layer.
These are 3D printers. They use thin layers of plastic, powder, even metal, to translate digital designs into physical objects. Companies like Autodesk make the design software which drives these printers.
I just go into the menu and I say print, and rather than sending it to a 2D printer, I send it to a 3D printer, and what comes out of it is this. So rather than the piece of paper that would have an image of it, here's the actual thing that comes out of the 3D printer.
Freely moving parts are possible because the machines can lay down a second material which supports the object during printing, but is dissolved away afterwards. All of these objects were printed in one go, no assembly required. 3D printing has been used for years in manufacturing to quickly and cheaply create prototypes before mass production. But 3D printers are changing.
The machines are evolving. The first thing is they're coming down in price, where they used to be in the hundreds of thousands of dollars. The cheapest one I've seen that's about to come to market is closer to a $5,000 price point, and the price of the material is also coming down as well.
Cheaper 3D printing is opening up whole new lines of business.
Instead of making one product a million times over, well, now you can make one product for one person.
Scott Summit, Chief Technology Officer of Bespoke Innovations in San Francisco, uses 3D printing to create prosthetic limbs.
What we're doing is using the person's own body to drive the design of what will create the prosthetic. It will scan the sound side leg, the remaining leg, mirror it over, which takes a fraction of a second on a computer, and then use that as reference geometry when we're creating the components of their prosthesis. This is a leg that is entirely printed as is, comes out of the machine ready to go. We've given it a very complex knee that would be prohibitively expensive otherwise, a foot that flexes pretty much like a real foot does.
But Mr. Summit is betting that 3D printing's personalized aesthetics will be as important as its technical precision.
The current prosthetic is an amazing piece of engineering and research, but it's half the equation. A person is about form and shape and beauty and sensuality. That won't be reached by an assemblage of off-the-shelf mechanical parts. This one was three-dimensionally printed like the others, but a few more processes take place after that. Leather can be wrapped around it, it can be metal plated. This is a prosthetic. It's just saying that a prosthetic can be a really beautiful thing and not simply a mechanical solution.
And as a follow-up to the New York Times video, I wanted to show you just a quick video of Vadim, who's our senior principal engineer in our materials department at New Product Development. We do, in fact, have a 3D printer, and I conduct a very brief interview with him that you might find interesting. I know I did. He gets into some very technical nomenclature that, if you're not an engineer, you might not understand it all, but you may pick up on a few concepts and terms that may be of interest. So enjoy. Okay, so I'm here with Vadim. He's our senior principal engineer for materials, and to his right we have a 3D printer.
Right.
And could you tell us a little bit, Vadim, about the printer itself and what advantages it gives Oshkosh Corporation?
Well, Don, this is it's a good question, and I wanted to clarify that this is, while we're calling this a 3D printer, in reality this is more of a concept modeler.
Okay.
This is a machine that's new on the market among many others. And these machines are used primarily for modeling concepts that are designed, that are created and designed by our engineers. And it's taken advantage of additive manufacturing principles as opposed to subtractive manufacturing, which would be your traditional CNC machining, where you remove material from a billet. In this case, what you do is you take a 3D geometry that you generate via your CAD software. You process it with specific type of software, where you slice it layer by layer and generate tool paths for these printers. And these tool paths are nothing but 2D cross sections of your part. So they're, if you can envision them, they're stacked layer by layer, and in three dimensions they they form your part. So this information is related to a concept modeler. In this specific case, this is a fused deposition modeler. And in this machine, what we're doing is we're feeding ABS plastic through a heated nozzle. And this plastic is, this material is being deposited through a nozzle, layer by layer. You start out with support material, which you can see right now. There's about 40 thousandths of support material that's generated to separate your part from the build platform. And then you progress to the part building stage.
So the advantage is that we don't have to send this off to like a machine shop to get it made and sent back here to get fit up, or
well, a lot of times what you're interested in is you're interested in getting your hands on a 3D model of your part, and if it's a smaller component that would fit within this build platform, or a larger component that you could possibly section into pieces and then put them together by gluing or some kind of bonding procedure, then yes, you can obtain a 3D model of your design, and then you can sort of look at it in 3D, understand form fit.
Okay.
A lot of times you could come up with several 3D models that would form an assembly, and that way you can really zero in on some of the shortcomings, potential shortcomings of that assembly, as opposed to trying to envision everything in 3D and potentially run into fit-up issues down the road. So this could really save you some time in troubleshooting your design.
Okay, so it saves you time and ultimately money, right, in the long run, without having to go through revision after revision after revision.
Right.
Okay. All right, that makes sense. Thank you very much,
You're
Vadim.
welcome.
Thank you.
Okay.
And that concludes my presentation. These are the references. I'll include the copy of the presentation so that you can actually get to the different references, and if you need to look at the videos, I thought they were very interesting. The Economist article is also very interesting. And discussion-wise, maybe to start it off, one of the things that I noticed on a blog was that if these 3D printers can be in the hands of anyone, it may cause some trouble with people producing illegal objects. So say, for example, illegal swords, brass knuckles, stuff like that shouldn't be on the street but make it onto the street. So that's a new phenomenon that creates new troubles and worries for people. So does the good outweigh the bad? That's maybe a question up for discussion and debate. So again, this is Don Phillips. Appreciate your time and hope you enjoyed the presentation, and have a great rest of the summer. Cheers.